Hi there, let's go over the answers to the topic 3 guiding questions. So the first one wants us to know what the easiest way is to produce a spectrum. So one way we can do this is to take a prism, and if we shine at a certain angle white light, the prism will break up into the colors of the rainbow, which is called an absorption spectrum. And so remember to try and understand what the colors of the rainbow look like for wavelength. We sometimes use the saying Roy G. Biv, where red is a longer wavelength than the V in Biv, which is violet, which has shorter wavelength. And I, of course, is indigo, blue, and so on. So that's our absorption spectrum, and that's how we might easily create one. Number 2, what's a spectroscope and spectral lines? We use the spectroscope in class, those black plastic devices, and if we pass light through a narrow slit before sending it through a prism, it can produce a spectrum which is very similar to what we used in class with those black devices. Here I'll draw you an example of what one looks like. So there's the black, the light comes in, and of course it goes through a slit and then through a prism, and a spectrum or colors of the rainbow are produced here for our eyes to see. Next, let's explain each of the following. What's emission or bright line spectrum? So what we can do is we can heat a gas at really low pressure to produce spectral lines. These are bright lines on a black background. So instead of having the colors of the rainbow produced, we have a black background and we get white lines depending on where they are in wavelength. What's a continuous spectrum? So if we heat a solid, liquid, or a gas at really high pressure and temperature, we can produce a spectrum of all the colors blending into one another. So again, a rainbow is a good example of that. Now, to be noted here is the following. If we have hydrogen that's heated and we put it through either a diffraction grating or a prism, and we look at the continuous spectrum, what can happen is we can get dark lines that interrupt the colors of the rainbow. That acts as a fingerprint for hydrogen. So absorption spectrum is the continuous spectrum light passed through a cooler substance, and that continuous spectrum will create these dark gaps between the colors of the rainbow, which are unique depending on the substance. So calcium would have a different absorption spectrum than hydrogen and helium. Let's keep going. Number 4, besides a prism, what else can we use to create a spectrum? Well, I just mentioned that in the previous question. Diffraction gratings can do this. So sound or light goes through a tiny slit and then spreads out again beyond that diffraction grating, and that can create a spectrum. Why is a diffraction grating used sometimes instead of a prism? Often it has a little bit better detail in the spectrum. 7, how can you use spectral lines to identify substances? Well, again, I talked about this earlier. Each element produces a unique pattern of spectral lines, almost like a fingerprint for that substance. So, for example, if we looked at the not the dark line spectrum, or not the absorption spectrum, but if we look at maybe the spectrum of calcium, there are 2 lines right there that make up the spectrum of calcium. Besides the composition of a star, what else can a spectroscope tell us about stars? Spectral analysis can be coupled with something called the Doppler effect, and it can help tell us whether a star is moving toward us or away from us thanks to a Doppler shift. And so let's talk more about that in the next question. Question 10, what is the Doppler effect? This is a phenomenon where there's a change in the pitch of sound or light as the object moves towards us. The radiation waves are closer together or higher in frequency, and that's moving towards us. If the sound or light rays given off by the object is moving away from us, then the radiation waves given off by that object moving away from us will have a lower pitch, and they will be farther apart when they reach us. And we call that part of Doppler effect or Doppler shift. Okay, so how does this relate to these two terms, blue shift and red shift? Well, a blue shift, according to the Doppler effect, means that it's a shortening of the light's wavelength as it moves toward us. So if these were the distances of the waves, if it was stationary, if the object was moving towards us, they'd look something like this. As you notice, they're compressed or closer together. And how does that relate to the concept of blue? Well, if we look at a spectral analysis of a star, if these were the marks which indicated what the composition of the star was when it was S for stationary, again, Roy G. Biv, so let's call this the red side of the spectrum, and let's call this the blue-ish side. If it was moving towards us, then here's what would happen. Those same spectral lines would be shifted over to the left, which indicates it's moving towards us, or blue shifted more towards the blue colors of the rainbow. If it's red shifted, then here's what happens. Here's the original star with its spectral lines. Those spectral lines now would be moved more towards the red side slightly, and we call that then red shifted. And that's it. That's the answers to our questions.